Good afternoon, everybody. So thanks for the opportunity to present our paper. This paper actually is extend our work with the recently workshop Halliman Symposium on Trustworthy Medical Robotics. So, so today I particularly provide a comprehensive framework for us to create a trustworthy medical robotics ecosystem. So firstly, I would like to, oh dear, this looks, so where? Firstly, I introduce why trustworthy medical robotics ecosystem is critically important in current stage of the arts, and extending the traditional performance metrics. And also we propose a layered-based medical robotics ecosystem and highlights 5 trust pillars and how can we layer mapping to each different trust pillars to guide us to design, employ, and development trustworthy medical robotics ecosystem. And then we introduce digital twin and blockchain technology, how they combine together reinforcement the trustworthy robotics, medical robotic ecosystem. And then based on previous introduction or proposals, we introduce a comprehensive trustworthy medical robotics ecosystem framework. Finally, we compare existing AI and robotics framework such as DSIT, IDEAL, and NIST framework. So to show how our trustworthy medical robot ecosystem framework allow us embedded these trust pillars to each component in the layered architecture to ensure our trustworthy medical robotics ecosystem to improve patient care and healthcare innovation. So this is today what we address. Because of timely, I just briefly go through this framework. So currently the robotics AI and the robotics technology develop very fast and already becomes essential in the healthcare delivery. So their research identified 10 different primary tasks in medical healthcare delivery. So here listed the 10 tasks. Of course, there are different aspects. Maybe there are different classification, but here the 10 classes of the medical robotics. So the first, I'm sure everybody knows the surgery robotics, and also rehabilitation, mobility, and social assistance. This is more popular for human because in the future, due to the aging population increased, so there's a lot of robotics might go to home, as we just talked about with our colleague here. So, and then we have telepresence and radiology and interventional. These two maybe can be included into the surgery robotics as well as somebody, and also pharmacy, delivery, transport, and disinfection. This part, telepresence and delivery, transport, and display, especially developed during COVID. So have a very important roles in healthcare delivery, all of these robotics. So there's a new concept we call the clinical cycle for patient. This is the increased concept used in clinical healthcare and research, especially the healthcare design. So because we consider human-centered ecosystem, so we use patient care clinical cycle from at the beginning, start to contact the healthcare providers and assess, evaluate, diagnosis, all, and treatment planning and treatment intervention, all of these processes, the whole process, to see how the patient provided health care to the patient. So this is what we consider, and we can see each stage we have robotics working in each stage. So this is particularly important that we can see how the robotics lower in these different stages. So that is also give our hint how we use the clinical cycle for a patient as a design base. So this is what I mentioned. So we talk about the trustworthy beyond the performance. And because my research is focused on human-centered AI for trustworthy robotics and autonomous system, so previous research I have considered very simple equations. Trustworthy, we know the high-performance AI. Every people want to do this. There's a lot of research on this, but the high-performance AI is not trustworthy AI. So we can simply explain trustworthy AI is trustworthy plus worthiness plus trustness. So this is what I think. But we think about the worthiness more reflect our high performance, speed, and efficiency. But how this reflect by trust? This is particularly important. So the trust is a reflection of the worthiness visible through the accountability, transparent explainability, all of this, and resilience. This reflects the worthiness. So this is what I say. So without the trustworthiness, so all the failures, explainability, safety, or alignment can have serious consequence in healthcare, because the healthcare system is a safety critical system. It's because the human is on the stack. So we particularly need to consider this. So failure, all of this will undermine clinical trust. So they might not put the intelligent system to their workflow, and also the cause patient harm, as we can imagine if the surgical robot has a failure problem, we can imagine how dangerous for human. So this is one, and also maybe the slow down the application or employment of the technology and leads to rejection and even the legal concern from the users. So this is particularly important. Of course, as I mentioned, many systems are built with performance as the primary goal. So how, rather than the embedding trust from the start. So this is the questions. How can we move from the high-performance AI system to our trustworthy AI system? This is a critical issue, questions we are needed to answer. So now I consider trustworthiness by design. So this is essential for medical robotics ecosystem. As I mentioned, so many problems is only consider performance rather than consider embedded trust. So because I mentioned the medical system is a safety critical system, so we need to ensure everything is okay under different conditions, even the system failure and any fault or cyber attacks. So we need to keep the system stable as its intended function. So this is the first thing. The second thing, we need to have ethical and legal accountability, because all the robots, maybe at the moment, the surgical robots is operated by the surgeons. So, but maybe in the future we have autonomous robotic system. How can we make the robots comply with ethics data protection, and such as GDPR, HIPAA, and the liability layer. So this is the second need concern, and the human-robotic interaction. So currently surgeon to operate the system, how make the surgeon confident to operate the system, confident with the applied action of the system. So this is very important, and also human accept this system or not, especially patient, right? And resilience and security in healthcare settings. As we know, the system is uncertainty and complex and dynamic environment. We need to deal all of this uncertainty issue, and also cyberspace might have cyber intrusion. This cyber attack might compromise the functionality. So the human on the stack maybe have in risk. So this is another issue. And also the system itself have fault or some failures. So we need to consider. And the alignment of human-centered AI principle. So this is a particular, we need to consider the regulation, reflect the human value and the human safety as a priority. So that reflect a human value while we achieve such a technology efficiency. So the last one, we need integration to healthcare ecosystem, ensuring interoperability, because the system is not a single one. It's operated with people and the regulator and the nurse and the surgery. So this is a particular, So I need to briefly introduce. So the architecture here, we introduce the hierarchical system. We can see all the systems. Here we can start from stakeholders, the human robotics interaction, cognitive intelligence, and the perception and the control, etc. But the most important, we suggest the two fundamental layers. One is a safety, security, and ethical layer. This ensure the trust of the ecosystem, and also data and the learning infrastructure. We link all the clinical healthcare system link with the data. So this data allow the federated learning, and the database allow us the system continuous improvement. So this is the structure we proposed. And also we have the derived with a modular layered architecture for the medical. Because of time limit, I don't want to say this too much. Just we think about each layer, need to consider all the strategy or how to keep this trustworthy. Here I just mentioned 5 trust pillars for medical robotics ecosystem. The first I already mentioned because of the safety and the running time assurance. This is particular in each layers, especially the hardware system. And the second, the security privacy, we need to consider. Security, we don't consider the intrusion because they link the internet, the cloud, and the infrastructure. So security we need to consider, and also privacy because the patient is a human. The data set is information, is personal information, is particular we need to protect from cyber intrusion or cyber risk. And as transparency explanation, we already mentioned that this is very important for ensure the clinical trust and the rely the action of the system. And ethical and legal accountability, we already mentioned this, and the life cycle. So this is 5 pillars. So this is a mapping. Each layer have different the mapping to different pillars. We have first and second, so indicate the importance in different layers, which pillars are most important. And also, on the other hand, this indicates each pillar, how they anchored in the different layers. So this, so here I've introduced as we say, that the digital technology have empowered the medical robotic system, ecosystem. So we can see how we have a digital twin, we have a blockchain, and also we have virtual reality, augmented reality, IoT, and real-time monitors. All of this technology ensure the medical robotics development. So this also, particularly, I want to mention the digital twin and blockchains give double insurance. So digital twin will ensure the system be monitored and real-time practical and simulation, because we can simulate do some planning, allow surgeon to rehearsal the procedure and on the patient specific models, and also practical monitoring and the life cycle synchronization. This is supporting incorporative operator decision-making with real-time feedback. Actually, in my opinion, this is a particular critical challenge, because the real-time reflector, they always have some delay, the system image and something else. So this is the digital twin and also blockchain system. We know, everybody knows blockchain is for the cybersecurity, provide a immutable, transparent ledger of surgical action and system update through three principles: decentralized, immutable ledger, patient-centered access control, and transparent audit till compliance. So blockchain provides, we can, as I mentioned, could be designed for ethical clinical cycle of patients. So to provide immutable and traceable data for evaluation, updates, and forensics. So this is a second insurance. Here I provide a comprehensive framework. We can see the three key components. The first, assurance fabric. So that means all the stakeholder intention and the regulators can embed with the whole system. And the second one, we use clinical device digital twin as a stack. So we can patient twin, device, and workflow twin to simulate the whole environment to ensure the safety, transparent accountability, and resilience. And then we have the third part is the blockchain as evidence ledger for the second insurance accountability and resilience. So this is our, and the last, just here, briefly compare with existing AI and robotics framework. As we know, we have DSIT framework, we have Leo IDEA framework, and NIST framework. There are different angles to discuss AI and framework, robotics framework. The idea is more than is for the clinical evaluation. The DSIT is general the guidance, the top level guidance for across different domains. And also the third NIST is mainly focused on risk management. So our framework is integration of the five pillars and also particularly highlights how we embedded all of this property into the system. So give a guidance for engineering to implement this system. So this is what our novelty here. So I just talk here. Thank you very much.